If you analyze a mechanical draft cooling tower or a cross-flow cooling tower, it might be necessary to specify the fan curve, and then you go to the fan tab. However, if you've selected under operating conditions that the air side is known, so you put it to specify. If you know what the airflow rate in kilograms per second is, no further action is necessary. It's not necessary to specify a fan. However, if you want the software to calculate the operating point of the cooling tower, you select calculate, you go to fan, and you specify the fan on this page. If you want to use a fan in the analysis, you only need to supply the input in these white blocks on the fan reference, fan specification, and fan static pressure. All the other information on this sheet is just for information purposes and is not used in the actual solving of the cooling tower. All the other tabs as well are there to enable you to specify the fan curve or to compare the fan. I'll discuss these in more detail later on, but for now it's just important to know that if you specify a fan, it is only these inputs that are necessary in the solution of the cooling tower. The equation that you enter here will be automatically plotted on this graph here for the static pressure. For instance, if we change that from 320 to 420, you can see that the values on this graph updates, and there it goes to almost 400. So, and this is typically the graph you'll see on a fan curve, and you have to fit an equation through this graph to get these coefficients over here. And we've built in a curve fitting tool that will help you to fit a curve, to find the polynomial, and to automatically update it and enter it into these blocks. The same process then needs to be followed to enter the equation for the fan shaft power and the fan efficiency. So the equation that you enter here, the curve for the fan shaft power will be plotted here as a function of the volume flow rate, and in this graph will the efficiency be plotted, fan efficiency based on the volume flow rate. If you make all the values 0, there will be no curve plotted over here. These two graphs are not necessary to calculate the performance of the cooling tower, although the fan shaft is a very important output of the cooling tower, because when you specify a fan, you want to know what the fan shaft power will be, and therefore it's very important to enter it, but it's not critical in the performance calculation of the cooling tower. It is only necessary to enter these values once. Then you can save all the data that you've entered, where by clicking on the write to table button, if you click write to table button, there's a fan table and you can build up your own fan database, and all the input values will appear here from the manufacturer, fan name, fan diameter, all the way to all the coefficients, and all of that is available. So then later on, if you want to select one of these fans, you select one fan and you say pick selection, and all of these values will be populated with the fan curve that you've selected. Another nice feature of the software is that you can compare different fan curves to each other or one another. You can select the fans that you've saved if you want to compare them. So here we select all the fans of a certain diameter and with different blade angles, and we want to see how the fans compare with regards to the fan shaft power, the fan pressure, as well as the fan efficiency. So then we click on compare fans, and then you go to the compare tab, and here you can see all the fan curves that you've selected. So it's the name of the manufacturer, the name of the fan that you've defined, as well as the diameter in meters, the number of fan blades, and then the angle that we've entered from 6 all the way to 26 degrees. And here you can see the volume flow rate versus the static pressure for all of the fans that you've selected. If we click on fan shaft power, you can see those curves, and then fan efficiency, you can see all of those curves. Generally, when you obtain fan curves from fan manufacturers, it will give you all the fan curves with a certain number of blade number, with a certain diameter, but where the angle varies from the smallest to the highest. And there you can see if the fan curves display that on the fan curve, so that you've entered all of the polynomials correctly. We're going to discuss next how to get the fan curves into the cooling tower software. Here we have an example of a fan curve obtained from a cooling tower fan manufacturer. There's a fan model number. This is specific example is for a fan with 8 blades. It's an 18 feet fan. The revs per minute is 190 and the air density is 1.2 kilograms per cubic meter. The graph at the bottom is the total pressure, fan shaft power, and then fan efficiency. And there's a different color curve for each fan blade angle from 7 degrees all the way up to 27 degrees. If we have a closer look at the total pressure versus the fan flow rate, we have this graph over here. Now the purpose then is to get all of these curves into the cooling tower software. Now what you need to do, and it depends on the shape of the curve, you have to identify a couple of values on the curve, and then we're going to use these values to fit the curve through the data. We're also going to do exactly the same for the fan shaft power, and we're going to start here with 7 degree fan blade angle. We also identify a couple of values on that curve, and then finally we're going to identify for the fan efficiency, identify values, and then we're going to enter these values in the software, and then we're going to fit the curve through those points. We're going to visually see if we're happy with that fit, and then we're going to save it into the fan table. Now I'm just going to show you how to conduct a curve fitting that we can save to this fan table. The points I'm going to input here are not necessarily the same as on the graph that I've shown you, but let's say for argument's sake we've identified points on a fan curve. So the first one was at the volume flow rate of 100, the next one at 135, 160, 190 and 210, and then the pressure drop, the pressure was then 160 pascals, 130, 105, 65, and you'll see it will start drawing a curve through all of those points. For the points that I've entered, that is not 0, and then the last point 40. You can see that it's fitting a curve through all those points that you've supplied, and it's also giving you an equation where y, which in this case, as you can see here, is pascals that we've entered, is 202.5052 minus 0.1012 times the volume flow rate minus 0.0032238 multiplied by the volume flow rate squared. Now sometimes the curve is not that good, and then you can play around with the degree of polynomial. So if I want to make it a 3, I can just click the up arrow and it will give me a third degree polynomial, and just to visually see if I'm getting a better fit. I recommend here that you use the one as low as possible, because if it extrapolates from the curve, that there are not any unintended consequences. Also very important is to note the minimum and maximum volume flow rate on which the curve is based, because you also have to enter that in the fan specification. So those two values you enter here, the minimum and the maximum. And if I'm happy with this, and this is for the fan pressure, I can say copy to fan static pressure. I hit copy, and now we can just verify if it's correct. I see that the first one is 144.1834. If I go to fan specification, you can see that it entered in these blocks all the coefficients that are necessary. Here I've entered points already to show the fan efficiency curve, and you can see if I select a degree of polynomial of 2, it's not looking as anticipated. Now I can increase the degree of polynomial to add more terms to it, and you can see it's looking better and better. Unfortunately, you'll see this should almost be a straight line between these 2 points, and this is telling me that I perhaps need to add 1 or 2 more points to make the curve more reliable. So I can add a point at, let's put that at 115. So I can put it at the bottom. The points that I enter here doesn't need to be in any sequence, and that number can also be 77.5 if it's a point in between. And now it will enter a point, and you can see the curve looks a lot better. And if I make that a 6th order polynomial, and it might even be necessary to add another point between those to make the curve even better. But this curve is looking a lot better. If I'm happy with that, I can say copy to fan efficiency. If I copy to fan efficiency, the first term is 0. I can go to the fan specification tab, and you can see it copied that into the fan efficiency. So you don't need to do a curve fit like in an external program like Excel. The last outstanding one is just the fan shaft power, and it's very important to note that it's in watt. In fan curves generally they give the fan shaft power in kilowatt, but just remember, if it's in kilowatt, you just need to multiply the numbers by 1000 to make it in watt. So you can do the same thing there. Before I enter it, I can just delete all the current values. So I can hit this button, initialize to 0, click on it, and it will make all the values 0, and I can enter the curve for the fan shaft power, hit copy to fan shaft power, it will do that, it will put them here. And before I save it, I can enter the fan reference conditions. The fan diameter in this case it's not a scale model, so I can put the actual fan there, the diameter and the density, and then these conditions here is for the fan applied in the cooling tower, but this is for the fan curve that I'm going to save. These fan specifications, these are not saved in the fan table. If I'm happy with all these values, I can put in the fan manufacturer, fan name, the blade angle, the number of blades. I can also put the minimum and maximum. This is quite important, because if it doesn't find the operating point between those values, it will warn you, and then maybe it's better to specify a different fan. So if I'm happy with this, I can save it to write to fan table, and if I go to fan table, it will appear at the bottom here. Lastly, I just want to stress again that the reason why these input values are not on a white background is because it's not that critical when you solve for the cooling tower performance when you select a fan. So all of these numbers are just for information, for you to identify the correct fan, and it will also give that as an output, but it doesn't need that in any calculation within the software. Secondary importance is the volume flow rate maximum and minimum. If it's below the minimum, it will warn you. If it's above the maximum, it will warn you. But again, it's not used in the calculation of the software. It can extrapolate, and it will give you a value for the performance. So yeah, just remember why these colors are not in a white background.